Bop, bop, bop. All right, we're recording and everything. Who are we missing? We're good? Okay, get ready to take notes now. Okay? This is note-taking time. This is a really easy, this first one is a really easy exercise in ratios. This is important when determining what is the right fertilizer for your project. Okay? So when we're looking at a complete fertilizer, complete meaning it has all the minerals in it, at least all three, and using fertilizer recommendations. Okay, so you send off your soil sample to the analytical laboratory, and they send it back to you, and they tell you that you need to put out 30 acres of nitrogen.
30 pounds.
Yeah, sorry, what did I say? I've been up here a while. Blah. 30 pounds per acre of nitrogen. Do I want to talk about this now or next? Hold on a second. Okay. I'm going to tell you a fact, a factoid, which will come into play in 1 second. But you need to know this factoid. That's not bright enough, is it? I keep taking all these back over here. Okay, you have NPK, right? NPK. That's a lie. That's BS. Okay? That's because the numbers that are on the side of a bag aren't NPK. What it is nitrogen, the form on which phosphorus can exist in an environment, and the form on which potassium can exist in an environment. Okay. Yeah, I haven't started that yet. Let's do this. When I ask you the question, what do the three numbers on the side of a bag mean? It means how much nitrogen, how much P2O5, and how much K2O there is. Phosphorus can't exist in an environment by itself like nitrogen can. Nitrogen can bond to itself at an N2 or bond with an oxygen and exist perfectly fine. Not until P bonds with itself and 5 oxygens can it exist in a solid form, solid granular form that is water soluble. Same with over here. It needs to be bonded with itself and have an oxygen on the side in order to exist as a granular form in a bag of fertilizer. That being said, this is a lie. This is the truth. Okay? Now, we'll talk about this in a second. Is it 43.6 or 46.3? I don't remember. Something like that. 83%. We'll talk about this in a second, but N, P2O5, K2O. The number that is written here on a bag of 1616 100% of the nitrogen or I'm sorry, 100% of the nitrogen available in the bag is reported by this number. Only 46% of the P that is in this bag is represented by this number here. This is going to confuse you. I'm going to go through in a second. This one is only 83% of this number. I'm going to do an equation in a second. Okay? But first, let's look at ratios. Remember I told you that it's not NPK, it's NP2O5K2O. So if you get a fertilizer recommendation from the Agriculture Center doing a report, and they tell you to put 30 pounds per acre of N, 40 pounds per acre of P2O5, and 80 pounds per acre of K2O. They're nice. This is a nice group of people that are doing your soil analysis. They're telling you that you don't need to... Most places will tell you you need to put out 80 pounds of P or 60 pounds of K per acre. This organization lets you know how many pounds of fertilizer you should put out based upon if you tell them what kind of fertilizer you're going to use. But given you need to put out these amounts of these different compounds, which are the ones on the side of the bag, we need to figure out which is the primary nutrient. Okay? Primary nutrient is usually the one you're trying to target first. 9 times out of 10, it's nitrogen. Oh, wait, can you point that camera at me? 9 times out of 10, it's nitrogen. So most of the time, when we're trying to figure out what our primary nutrient is, the one we're trying to meet first is going to be nitrogen. So let's figure out what the priority nutrient ratio is. I know that my primary nutrient, the one I'm trying to get to by putting in fertilizers, and the one I'm trying to meet with my first application is going to be nitrogen, and that requirement is 30 pounds per acre. So what I do is I take this weight of my primary nutrient, 30 pounds, and I divide it into the weights of each of them. Okay? So 30 divided by 30 equals 1. Your primary nutrient you're trying to figure out, if you're trying to figure out the ratio, always should be 1. You're always going to take your primary nutrient and divide it by itself. Should always be 1. So when you look at your homework and it asks you what is the ratio there, you should be able to answer at least nitrogen right off the bat. I take 40 pounds per acre of P2O5 and I divide that by 30. It goes 1.33. I take 80 pounds per acre of K2O, I divide it by 30. It goes 2.67. The answer to this question is, what's my ratio for my primary nutrient? For every 1 part nitrogen requirement I'm meeting with my fertilizer, I'm also meeting the requirement of 1.3 parts P and 2.67 parts of K. Do you get the equation? You just don't know why. Okay, I haven't told you why yet. So when I'm doing a complete fertilizer, and I have, say, 1616, and I'm trying to meet my requirement, I know that if I put out 30 pounds of 1616, I will meet my end requirement. And because those other 2 16s were on there, I'm meeting some of the requirement over here too. What proportion? This proportion. So, that being said, when I put in 1616, it looks like it's obvious I'm going to have to add a little bit more P and a lot more K to meet my requirement. It's just a visual. I've already met my nitrogen requirement. This is a visual of about proportionally how much more I need to put out of an incomplete fertilizer. We'll get to this. Does everybody understand that so far? Okay. It's strictly just a visual to see proportionally if you're meeting the requirements by putting out 1616 or whatever complete fertilizer you have. Okay. Given these three right here, give me the answer. Which one has which one comes closest to the required ratio? Here's your required ratio. 1, 1.33, 2.67. Which one of these would meet that requirement? Good guess, good guess. Anybody else got an answer? Well, let's look at them each. I take my primary nutrient, nitrogen, and I divide it into the other two. Just like I did before, here's my ratio. That's nowhere near 1.33, 2.67, right? It's nowhere near. That's not an option for me. I don't want to do 1010. Trick question. If you see colons, it's already a ratio. Okay? So, that doesn't look anything like 1, like, what is it? Blah, 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 blah. Also, you can't have this, right? Because this always has to be a 1 first. 618. Let's simplify it. Ratio of 1, 1, 3. 1 part here, 1 part here, 3 times as many here, right? That's pretty darn close to what I'm trying to meet. Maybe this is, if this is my only option, that this is going to be the fertilizer for me. Okay? Let's look at fertilizer rate. I know I need to put out 30 pounds per acre of nitrogen. Forget I just started. Let's talk a little bit about what this number means, right? This number is the percent N in 1 pound of fertilizer. That's what that number means. If I have 1616, it means that if I take 1 pound of this fertilizer, I got a 50-pound bag, right? I take out 1 pound of it. I have 1 pound in my hand. Only 16% of that material is nitrogen. Okay? That's what this is telling me. Same with P2O5 and K2O. It's the percent in 1 pound of fertilizer. Do not forget that. 6 turned into a percent. 6% turned into a decimal is what? 0.06, right? You take the decimal point and go 2 points over. That's how I got this number right here. I know that I need 30 pounds of N per acre. I know that 0.06 of a pound of N I know I need to put out 500 pounds of 6,618 per acre to meet my nitrogen requirement. You see how I did that? All I do is this simple. Write down these steps to answer your homework. Write it right on your homework for this question. You take the primary nutrient you're trying to reach. You divide it by the decimal that is created by the percent on the first number. 30 divided by 0.06 tells me that is that camera at me again? No worries. No worries, no worries. Okay, so I take 30 divided by the percent in decimal form, and that tells me how many pounds of that am I going to need to meet my nitrogen requirement. That simple, super easy. It looks more complicated than it is. Here's where it gets complicated. Now, what requirement am I meeting for my P2O5 and my K2O? By putting in 500 pounds of 6,618. Let's find out. I do that by taking my weight of the amount that I'm putting out to meet my primary nutrient requirement, which is right here, 500 pounds, right? I know that I need 500 pounds of 6,618 per acre. I take the decimal on my next one over, which is 0.06, just the same as the first, and I multiply this weight times this percentage in decimal form. Gives me an answer of 30 pounds per acre of P2O5. Let's look at K. Same thing. I take my weight, I multiply it by the percentage in decimal form, and it tells me that I will be, if I add 6,618, if I add 500 pounds of it, I will be adding in 90 pounds of K2O. Got that? Real simple equation? You're shaking your head no.
Where did you get the 500 pounds?
30 divided by 0.06 gives you 500. It's that easy. It's all right here, right in front of you. Take this, divide it by the percentage, equals the weight. You take the weight, you times it by the percentage, and then the weight times it by the percentage. Super simple, if you know what you're doing. Now, let's see if we met our requirements. Well, I found out that I will be, in addition to meeting my nitrogen requirement, I'll be adding 30 pounds per acre of P2O5 and 90 pounds per acre of K2O. I just figured that out, right? Well, my given requirement that the analytical laboratory told me, I need to put out 30 pounds of N, 40 pounds of P2O5, and 80 pounds of K2O. Well, I'm getting pretty close to meeting my requirement, right? 30 pounds per acre of P2O, and I'm supposed to put in 40. So I'll take that number 40 that I'm supposed to put in, take that number that I am putting in, and figure out how much is left over. Got that? I'm stopping if I know you're not understanding what I'm talking about. What do you want to know? Let me help you. Yeah, so you're coming really close to what you're needing, or what is recommended, right? So somehow along the way, we're going to have to add that extra 10 pounds per acre of P at some point. Right now, we're only putting out that initial fertilizer still. Right. Well, at 90 pounds of K2O, I'm already meeting my 80-pound requirement K2O, right? So by adding down 500 pounds to meet my N requirement of that specific fertilizer, I am already meeting my K2O requirement. So now I've met nitrogen and K. And I just need to find a small source for that 10 pounds per acre of P. Okay? Now, you can make a decision. Guy like me, I'm done. I've already met my K requirement, I've met my N requirement, and I'm pretty damn close to my P requirement. I'm done. I'm going to put that out, and I'm going to go with what I got. That's just the way I am. I'm not going to, it's very, very difficult and expensive to go out. Is it worth the money to go out and buy a bag at $50 a bag to add that 10 pounds per acre in? I don't know. If it cost me $300 extra for that small amount, I don't really know. It's just a recommendation. It's not a requirement. So it's not like if I don't put exactly this amount, all my plants are going to die. No, might not reach the full potential of what those people think I need to do. Okay, so it's your decision. You can refer to the P2O5 and the K2O recommendations and add remaining necessary P2O and the K, actually you already meet that, using an incomplete fertilizer. So if I was to say use rock phosphate, which is an organic source of phosphorus, fortunately mined out of the ground in Montana and shipped over, super cheap though, and readily available to plants once you put it in the soil. Rock phosphate has a 030. It's an incomplete fertilizer. Or maybe sulfate of potash if I wanted to get closer, or adding more K2O if I felt like there was a need. But what I would do then, if I really, really wanted to, and I wanted to meet that requirement, was go in with a incomplete fertilizer and then just put in just enough to meet that requirement for 10 pounds per acre, and boom, I just met my requirement. And what did I do? I put out one type of fertilizer and then a little sprinkle of another, and I'm done. There's no waste. I'm not putting out more than I need to. Ooh, I even do the equation. So I don't know if you need to know this, but if you go rock phosphate is 030, it's real simple. I mean, it's just that easy. I know that I have 10 pounds I still need to meet, right? That was on the last one. I have 10 pounds I still need to meet. I divide that by the decimal percentage of the phosphorus that is available in rock phosphate. Once I take 10 divided by 0.03, that's 333 pounds of rock phosphate I need to buy to meet that 10 pounds per acre requirement. Rock phosphate comes in 50-pound bags. How many bags do I need to buy? I need to buy 6.66 bags. Well, they don't sell 6.66 bags. You can only buy whole bags, so you got to buy 7. 7 bags at $11 a piece. Is that worth it? Probably. You only put out 100 and some odd of extra bucks to make sure that your fruit stays super nice. It might be worth it. Yeah, it's hauling the 330 pounds around and all that stuff that I wouldn't even know if that's worth the $100. I don't like lifting things. Got that calculation, guys? Next one. We're talking about this elemental forms that I just talked about. Now, be sure you write this down. NPK is a lie, right? It's actually NP2O5K2O. This is the amount of the percentages that are available. I put that up on the board over there. Be sure you write that down. You're going to need that to do your homework. By the way, you have 2 weeks to do this homework, so no excuses, guys. I will be able to answer emails and answer questions, okay? All right. 100% available by this number. 43.6% of this is actual P. And 83% of this is K. Everybody understands that? Okay. We're getting there, guys. Almost done. All right. If I am given, I'm told to use 12, 6, 28. How much percentage of that number is elemental NPK? Elemental meaning by itself, not P2O5, not K2O, just NPK. What percentage? Let's go through it. Plain and simple. 100% of this is available. Okay, so we don't really even need to do an equation. You take this number, that's your answer for N, for elemental. P gets a little more tricky. Take this number here. Don't change it to a percent. It is a percent. Okay? You're going to multiply that by the percent I just gave you of elemental P in decimal form. Okay? Imagine there's a percent here, right? Next to the 6. That percent needs to carry over here, right? Old school math. It's got to carry that label over. So if you took two percentages and times them against each other, you're going to, yes, get a percentage, but be totally wrong, right? So we want to make sure that you do the percentage in percent so that you can carry that label over, and then you do the percentage in decimal form. 6 times 4.36 equals 2.6%. That's how much that's how much elemental P is in that 12, 6, 28. Let's do the same thing for K. 28 times 0.83 equals 23.2%. Why is this important? Well, maybe you don't have a nice analytical laboratory. I got a lot of places, especially when you talk about when you do a tissue analysis, they'll usually tell you what you need to put out in elemental. So you need to know how to be able to do that conversion on the side of the bag. If they tell you you need to put out 6% or whatever, but you know that through the equation you're only going to meet 2.6%, then you're going to have to multiply the amount you're going to put out to meet that requirement. Okay? Let's do this. Given 10, 5, 16 in a 50-pound bag, how many pounds of nitrogen are in the bag? 50 pounds. Good answer. Okay. 10. Right? Okay, this is how I do this. Most fertilizers come in a 50-pound bag, right? Almost all of them do. Okay? Percentage, when we're talking about numbers in percentage, it's on a 0 to 100, right? Percentage only goes from 0 to 100. Okay? If this number was 100 pounds, what would the answer be for N? 10. Okay? So as a smart trick, knowing that most of them come in 50-pound bags and that your percentage is on a 100-point scale, if you take this number and cut it in half, you get your answer, 2.58. I could sit here and explain to you how to work out this equation, or you can do it that way, which is the most accepted way to do it. It's much easier. It's like figuring out the tip for your waiter. much easier.